A variogram is a mathematical model that describes the spatial variability of the subsurface and helps us understand how changes in the property occur over distance. If the subsurface is generally homogeneous, the property values are easily predictable with little variation. A variogram indicates how much a property is expected to change over a certain distance. This correlation is used to make predictions about changes that are not necessarily linear or exponential. For example, if we had decided to drill boreholes to check the temperature at a depth of 100 meters, the results would be as follows. In the first borehole, we recorded a temperature of 15.5 degrees Celsius. The second borehole, which was 20 kilometers away from the first, recorded 20 degrees. The subsequent borehole was closer, and the temperature difference was not as significant. As we drilled boreholes closer to the first one, the temperature difference dropped. The final borehole, located approximately 1 kilometer away from the first one, showed no difference in temperature. The simple example I showed represents 5 pairs of data points. Each pair is described by a distance between points and the temperature difference. If we wanted to consider all distances between these boreholes, we would have 15 unique pairs. Because to construct a variogram we need a significant amount of data, pairs are grouped based on their distances within lag distance classes. For example, a lag distance of 10 meters will group pairs of points that are 0 to 10 meters apart. The next group will include points which are 10 to 20 meters apart, and so on. The differences in value of an interpolated parameter are then squared. The variogram value for a particular lag distance is then calculated by averaging these squared differences. The result is the variogram value at that lag distance, here marked as d1. We start by looking at how much a parameter changes between 2 points that are a certain distance apart, referred to here as d1. We then square this change to ensure that all our results are positive. The average of all these squared changes is called the variogram value for the distance of d1. The variogram value at d1 tells us how much we can expect the value to change between any 2 points that are d1 distance apart. When the distance between 2 points is so small that we cannot measure any correlation between them, it's referred to as a nugget. This term is derived from the nugget effect, which describes such random concentrations of mineral deposits that their locations cannot be predicted. Similarly, there is a concept of range. It denotes a large distance beyond which there is no correlation between data points, or the relationship is no longer useful for interpolation. Once we have constructed variogram, we can predict properties between sampling points using Kriging interpolation methods or geostatistical simulations. Kriging was explored in the previous episodes. We will also talk about geostatistical simulations, which allow us to construct multiple possible models and then estimate their probability. Thank you for your time.